everyone, and thank you very much for joining us for this part of the Global Urban Air Summit. Autonomous flight is a key aspiration for the change that this exciting sector is promising to bring to aviation. It's a very complex topic. Some would say it's contentious. And so we're fortunate to be joined by five genuine experts who are at the forefront of making autonomy a reality. They're coming at the subject from different places, but I'm pretty sure they're all heading in the same direction. Let's find out. First, we have Florian Michael Adolf, who is head of autonomous flight with eVTOL developer Volocopter. They're based in Germany and they're developing the Velocity aircraft for mainly air taxi operations. Simon Davis is a very experienced experimental and research test pilot with D5 Aviation, which is supporting efforts to introduce eVTOL aircraft to the market. Jia Zhu is Senior Director of Strategy Planning for Honeywell's new UAM/UAS business unit. That was established in June, specifically to tap the potential for the urban air mobility and UAS sectors. And it's harnessing the company's expertise in advanced flight systems, propulsion, sensors, and controls. Jay Merkel is Executive Director for the U.S. Federal Aviation Administration's UAS office. And David Tate, on this side of the Atlantic, is Head of Innovation with the UK's Civil Aviation Authority. He's been leading the agency's work to promote the development of various eVTOL and unmanned aircraft technologies. Well, we're here to talk about how far we can go with autonomy, but first I'd like us to consider how far we should go and why we even need to go there at all. Let's focus on the operational use and business cases before we get to the safety case, because without that, the first two are probably non-starters. Florian, I'm going to start with you. Your Velocity eVTOL aircraft is being flown by a pilot today, and it's set to enter service that way, perhaps as early as 2022. But I believe your goal ultimately is for autonomous operations. Why does that matter to you and your business model? Is it necessary and desirable, or just desirable? Please tell us.
Yeah, thank you, Charles, for that great question. I think it's a good pitch to actually get a feeling on where autonomy will help us. Along the way, the initial operations, that's really to get the aircraft safe into the air, establish a commercial operation, and get everything working without a lot of automation involved. That's what everyone did over the past decades, also when the conventional aviation, as we know it, was basically introduced. But then it's a wise step to also automate as much as possible to be more effective, more efficiently, and especially on board. I mean, in our case, as you may see for the Volocopter 2X, which is behind me, it's a two-seater. We have to start small for an eVTOL. So that's what you can also read in our white paper, and that was released last year. We believe that it is a wise decision to start early, but then take the pilot out as soon as it's possible to do so and safely. So I think we definitely have to go down that path together with the regulators in order to establish a safe way of automating that.
Thank you very much, Florian. We'll get to the regulators in a minute. But Jia, companies like Honeywell are supposed to be where the autonomous magic is going to happen in terms of the ability to harness technologies like artificial intelligence and machine learning. So again, just because you feel you can achieve this, why do you think it matters so much?
Yeah, thank you, Charles. And it's a pleasure to join this panel today on this important subject. At Honeywell, we have a vision that the future of air cargo will be completely autonomous from warehouse to your house. And urban and regional air travel will be ubiquitous and accessible with electrified and highly autonomous aircraft. And that's why we're building integrated propulsion and avionics systems for UAM and UAS to make that future a reality. And to your point, we believe this future very much needs autonomy, right? We need to eliminate the preventable operator errors and improve aviation safety. We have to, as previously said, improve the unit economics of UAM because now we're carrying fewer people with the same pilot. And we have to enable new services like drone parcel delivery or fulfillment center connectors where we can't physically fit the pilot on the aircraft. And finally, let's not forget, it's not just about the airplane. We also need to introduce autonomy into the airspace system to enable high volume operations. And to those points, Honeywell has been working on this, and we have a number of proof points. Our compact fly-by-wire system is now in the vertical aerospace UAM platform. Our citizen detect radar solution has now been demonstrated on helicopter and UAVs, and we have supplied this radar to UAM companies. And we have also just recently demonstrated autonomous landing using helicopters as well as a leading UAM platform. So, we very much believe autonomy is important, and we're taking a no magic, step-by-step approach to get there.
Thank you very much. Simon, you earn your living as a pilot, essentially. If I may be blunt, why are you advocating for autonomous flight? Doesn't that make you a turkey voting for Christmas? But seriously, putting that aside, and the user cases that your colleagues have addressed, how do you view the safety case for this step? In what sort of circumstances do you see increased autonomy positively enhancing safety? And do you see this as more of a journey in which automation progressively increases until we reach autonomous flight?
Thanks, Charles, and thanks for having me today. Turkey's voting for Christmas. I think there will always be fascinating and interesting jobs in aerospace for whoever wants to be involved, and the nature of those jobs might change. But so I'm not worried about the short. I'm not worried about the medium or long term. In the short term, I think autonomy for especially passenger carrying operations is a little way away. And to get to the second part of your question, what about the journey? Jean has talked a lot about automation of cargo operations, and I think we'll see a twin track approach here. You'll see eVTOL aircraft develop in market forming and market shaping activities to develop these new markets, but probably with pilots in control, flying people around. At the same time, we'll see increasingly autonomous unmanned operations, initially in segregated airspace and then into the wider airspaces as unified traffic management develops. And eventually you can see that some way down the road, once we have more confidence in the automation and more importantly, once there is acceptance of automation from a human point of view, not just am I comfortable with this flying over my house, but am I okay sending my kids to school on these platforms, then you'll start to see those technologies converge. So I think very much a twin track approach to development towards passenger services.
Sure. So going at different speeds, but in the same direction in terms of fully autonomous flight being the objective. So Jay, if I can switch to you, FAA is very clearly focused on the potential for autonomous flight. I know your team has and continues to do a lot of work on this, and of course, including in the context of small drones. In your view, putting commercial considerations to one side, what benefit does autonomy bring to the operation of larger eVTOL aircraft carrying people and things, and potentially into quite crowded urban airspace?
Oh, thank you for the question, and thank you for having me here today. The real benefit goes back to what Florian and David both mentioned, and that is it's about finding those places where human error is making the safety system very fragile, right? We've seen it over and over again. While at the same time, the progression towards autonomy must also recognize that the plasticity and the ability of humans to deal with off-nominal cases is very valuable in flight. So we definitely see this progression. We see this progression, and we have projects in type certification right now that are pilot optional, safety pilot, and working towards fully autonomous. So whether highly automated or fully autonomous, we're working through that progression and finding what are the safety parameters that must be addressed as we move to more and more autonomous operations. And you're right, it also has to do with autonomy in the airspace, particularly for air traffic controllers. Knowing the predictable behavior of these aircraft in off-nominal conditions, that is so vital for the safety of the airspace. We take it for granted how ingrained it is in legacy aviation, but we have to develop those same patterns for highly automated or autonomous aviation.
Mm-hmm. Thanks very much, Jay. Now, David, you're in the UK with the CAA, and I understand that you've run a program, a first round of a program called the Future Flight Challenge. Um, I understand that the majority of user cases in the first round were considered somewhat poor. Is that right? And if so, to what extent was perhaps a failure to take account of the potential for autonomous flight a factor in that?
And thanks very much for the question, Charles, and thanks for having me here today. I think to be clear, Future Flight is actually a program of UKRI, UK Research and Innovation, and
You're
the
right.
CA is a supporter. So I'm afraid I can't comment so much on that process. But I think to speak to the general thrust of the question, why is that going to be important as a factor in Future Flight? I think the three use cases that Future Flight is focused on, in the end, are about integrating new types of aviation, whether it's UAS operations or future mobility or non-hydrocarbon based propulsion models into a legacy airspace and aviation system. And so I think that's going to be the interesting challenge. Is how do we introduce these increasingly autonomous systems into an aviation network that also at the same time is operating on, in some cases, purely pilot or ATCO-driven systems, which are effectively just it's the rule set that provides the safety with the assistance of the pilot or the air traffic controller, with very little exchange of data beyond voice data. And that is going to be an interesting challenge, how we bring that incredibly rich environment of non-digital data and integrate it with systems. And I think one of the important parts about when we're talking about autonomous or increasingly automated systems is that that's a combination of both the decision-making component of the algorithms or the neural net or whatever we're talking about, as well as the integrity of the sensors that are relaying the data to them. So that in itself is an incredibly complex proposition, allied to which integrating legacy systems and actors, for example, in general aviation, who will want to continue to fly under their own power and in accordance with visual flight rules or instrument flight rules, that's an interesting challenge. And I think that is going to test the limits of both the technology and the regulatory rule set.
Yeah, good point. Let's just quickly look at this through what I'd call the other end of the telescope. Given the predicted complexity, David, of future airspace, where we're going to have, delivery and service drones sharing space with conventional aircraft and urban air taxis, could we say that safe flight would even be possible without high degrees of autonomy? To take account of the sort of volume and complexity of all this traffic that's having to be managed.
Yeah, I mean, I think that's an interesting point, and perhaps one of the things we haven't quite touched on yet as the key drivers for this is that we don't have enough pilots or air traffic controllers in the world to meet what the existing demand for the projected demand for manned flight will be, let alone autonomous flight. So I think that's an interesting driver. But I think absolutely that we have to be thinking about how do we respond to that challenge? Yeah.
Good. Okay. Well, thank you, everybody. Now let's turn our attention to how far we can go with autonomy and what stops we may need to take along the way and what we'll need to do to get there, wherever there ends up being. Jay, I'd like to go back to you. In your view, what are the key safety elements for autonomous flight and how do you rate the industry's prospects for meeting these requirements?
First, I want to start with an apology to both Simon and David. I accidentally exchanged your names earlier. I apologize. It's been that kind of a day. My day, but it really does go back to what are not just the nominal conditions, but how do we manage the off nominal? And I think industry has been demonstrating that they're meeting that challenge. And as we grow and we learn more, we are making good progress. And it's really, I think, to think of autonomy or highly automated as an end goal, it sounds kind of scary. I remember entering university thinking I would never get through 4 years, right? And then all of a sudden, I was done. And it was just those gradual steps. And I think we need to recognize that from legacy aviation and from these new entrants like small unmanned aircraft systems, we've been making progression towards this autonomy for years. It started with replacing flight engineers and navigators and going down to the two-person cockpit, right? That was revolutionary automation at that time. We just certified an auto land system for general aviation here in the United States. You know, a very important safety feature in case the pilot is incapacitated in any way. So we do see that industry is continuing, and companies like Honeywell are making great strides in demonstrating and building brick on brick on brick. So yes, the building will get done, but yes, there are also many bricks to put in place. And it's really understanding those off nominals that are the challenge.
Yeah. Okay. So obviously, you know, it's pretty clear that there are multiple urban air mobility eVTOL aircraft progressing towards certification at the moment, or at least taking their first steps. What sort of implications are there for people trying to certify this type of aircraft if they intend to fly autonomously, and especially for passenger carrying flights? I mean, is that a sort of a whole different certification path, or just you know, a slight sub path that has to be followed at some point on the way?
At least for us, and I'll let David speak to it for the UK CAA, it's the same exact certification path, and it's the same exact safety expectations, because it's the same exact hazards. The air hazards are the same, the ground risk is the same, the aircraft reliability must be demonstrated. And I think that's the challenge, is what constitutes demonstrating the safety level associated with the level of autonomy. What is the data? And I think the pioneers in this space, along with us, being the first in any of these is difficult. Being the 15th is a lot easier, right? So companies like Velocopter, I'm sure, feel tortured at times by the continuous questioning and grasping for data. But it's how do you build that safety case, and when do you feel confident you've collected enough the data to demonstrate you've met that level of safety that's expected to carry humans and to mitigate the air risk and the ground risk?
Yeah, very good point. Well, Florian, we're going to come to you next as it happens, and I hope you're not being tortured, but I do know that you've been working in a very focused way with EASA in Europe. What can you tell us about what EASA is going to expect of you and other eVTOL pioneer companies in achieving autonomous flight operations?
Yeah, it's also definitely a great outlook that we have there in the first place. So the regulators to be extremely constructive and open to learn together with us as we go down that path. So nobody knows the solution in that sense, as Jay rightly said. So we all are going to be the first, and it will be a difficult ride once in a while. But then on the other hand, there are a lot of technologies out there where we already know they exist for years and years in the mass market, and they work, but we have to make sure that we can prove they work prior to flight. I mean, you can't just, as opposed to autonomous driving, for example, everyone can technically take a car and put it on a test track. You can't just do that with a proper aircraft. You have to integrate it properly, have the right procedures, and really handle it safe. So when it comes to autonomy, and first of all, maybe we talk about our old definition about what we think is autonomous in the first place. So we, together with EASA, we actually are very realistic here that the first important step to take is everything with the pilot still on the loop, so not tightly in the loop, which is not really a business case in that sense, but I think a pilot on the loop is the way to go, and that is the first mission to resolve. It's like landing on the moon, and then maybe later we can land on Mars. So basically, that's what we should aim for. And yeah, coming to the other point on the economics and the business case there, I think EASA is extremely supportive. They're realistic, but on the other hand, they're of course not stepping down from the requirements. So we have to work hard to fulfill them. And so we have to put everything into the basket in terms of technologies and ideas and just try them out. So we also need some room to play together with them so that both of us can learn as technology progresses. And the most important part there, obviously, is the data about it. So that is the ultimate proof. As long as you don't have the data, you just have an opinion.
Yeah. No, that's a very good point, and I know that's why you're putting so much work into gathering that real data to prove the safety case. Some people, I should say, tend to view pilots as potentially a sort of weak link in the safety chain. But is the industry making maybe too many assumptions about how reliable artificial intelligence is? I mean, what sort of testing will artificial intelligence systems be subjected to in the context of verification, validation, and certification?
It's a good question. First of all, I haven't checked out everybody on LinkedIn, but I am still sure, given this audience, that Simon is probably not the only expert pilot here. So given that, I don't really want to think of pilots as the weak link, right? Rather, I believe that we have this amazing opportunity to make the human-machine team stronger together, right? Because we're so good at so different things. And this is why Honeywell is, to the points mentioned earlier, investing heavily in simplified vehicle operations, because that's a pathway where the human and machine can be better together, and the machines can crunch the numbers, and the human can deal with the plastic conditions, the context switching, the off-nominal conditions, right? But all of that said, we do face some challenges, to be sure, in verification and in certification, right? So we look at the complex black box type autonomy engines, right? We're worried about interpretability. Do we understand how we got to the answer, and do we understand it sufficiently to trust the outputs? We have to worry about generalizability and robustness, right? So if we change the input parameters a little bit, do the output vary radically and in unexpected ways? We can't have that, right? And finally, in the case of these learning-based systems, right, we have to be worried about biases in the data, about the potential for adversarial attack. Do we then have safe and representative data to train the machines on, right? But I think to Jay's point, and this is how we think about it at Honeywell as well, having had so many years of experience building the world's first autopilot and then getting our way onto 90% of the commercial aircraft out there, our certification system today is very much geared toward certifying complex cyber-physical systems, right? And what is autonomy but the sum of complex cyber-physical systems? So I think many of the best practices will therefore carry over, right? Things like formal requirement review and verification, modeling and simulation, and integration and flight tests to test the end-to-end system, right? And where we have to maybe extend our certification regime is in situations where we have to leverage machine learning, where the onerous shifts from procedural programming, verification, and into the data, and how that whole data is processed, is curated, and the machine learning models and architectures. So to tackle some of these challenges, Honeywell is building a full-scale UAM integration lab, right? We're wanting to scale up our modeling and simulation capability, find the corner cases, and demonstrate complex autonomy and human-machine interfaces. So, finally, this is why the panel is here today. This takes a whole village, right? We need to get regulators, academia, industry working together on this. And I think we're also fortunate in the sense that really mission-critical autonomy and AI/ML and how to assure them, that's not just a aerospace problem. That's a society problem, right? It impacts every aspect of our lives. And as an industry, I think we have to apply, best practices across industry lines. Maybe the best ideas comes from insurance or fraud detection, right? We have to be cognizant of that.
Yeah, fair enough. Well, let's cross the village to you, David, in the UK. Can you just give us some idea of how the CAA is playing a role in creating an environment in which the industry can build a safety case for autonomous operations? Just give us some sense of how you're engaged in this process.
Yeah, absolutely. I think everything that's been said there is really spot on with the approach that we're taking. We believe it's going to be an iterative approach. We believe that we have to, as a regulator, engage directly with those who are developing these new technologies. And we're doing that through our Sandbox initiative, where we've partnered with a number of developers to tackle these really complex problems. To give one example and use case, one of the first entrants into our sandbox was NATS, the UK ANSP, who's working with Searidge Technologies, a Canadian developer, to deploy an in-tower AI assistant at Heathrow. That assistant, Amy, assists air traffic controllers with ground movements and ensuring runway clearance. So it's really been interesting for us is to collaborate with NATS and Searidge and observe how that technology is performing alongside the air traffic controllers in the tower. And so that gives us tremendous insights into what's going on and to how that technology is performing and what the parameters of that performance are. And what's very important, it goes to a lot of the points that have been made about off-nominal circumstances, is the extent to which it is capable of dealing with and surfacing those off-nominal occurrences to the air traffic controller and effectively giving them the best information to make their decisions. And that's really what we're looking at this stage of autonomy, is not taking the human out of the loop, but improving their ability to make the correct decisions. And so the responsibility and the operational integrity sits with the air traffic controller, but they are assisted to make the right decisions by having the best possible information and the assistance of the AI in performing those computational functions that it is potentially better at. So using that sandbox approach has been great for us to really get under the hood of that type of technology. And that's the approach that we're taking further. Another sandbox participant with us is Volocopter. So it's really been it's been great for us to be able to work with a UM developer specifically on that challenge. And so we've also just launched our another sandbox challenge call for future air mobility, looking for more OEMs in the urban air mobility space to come and join us in the sandbox and partner to think about how we tackle these challenges.
Thanks very much, David. Simon, you're a human still very much in the loop. Can you describe to us how test pilots like yourself can help in the process of proving the safety limits for autonomy? And is it a case that of establishing that these systems directly replicate human flying? And if that's so, then how can the industry take account of all the possible complex variables involved in flying when they're developing autonomous systems?
Well, that's a very good point, and it's been Jay said something similar, but actually safety in aviation with a pilot involved, it's a pretty high bar actually to beat. We've spent 100 years investing on that human machine interaction, and we're not going to throw that away overnight. So it's an iterative approach. David mentioned simplified vehicle operations, and I think that's really the key to working through some of these really complex automated problems in automation. You take the data that the pilot sees, then the system makes a prediction. This is a likely outcome, and here are your options to deal with that outcome, whatever that means, a pending engine failure, deteriorating weather. And once you're testing that logic out in the real world with pilots in the loop, you really start to understand the if then situations. And I think what increasingly we see evidence that what appears off nominal to a person is slightly different to what appears off nominal for a machine in some situations, and there's a lot we still need to learn, I think.
Yeah, thanks very much, Simon. Jay, back to you. Now, FAA fairly recently has issued a new concept of operations set of guidelines for unmanned air traffic management. How will these tie in potentially to the advancement of autonomous flight more widely?
Well, the new concept around UAS traffic management was born out of the recognition that when small UAS got to a density in the airspace, there was absolutely no way that we could hire enough controllers or field enough equipment to manage them. And we needed a completely new approach. And we from the beginning went with a very automated approach. We do expect that as the density of these operations increase and we see these technologies mature under UTM, we will see technologies or procedures or operations that may translate well in probably initially in the urban air mobility or advanced air mobility area, and probably maybe eventually make it to places like human transportation. But I think for some time we'll see these two parallel paths where the urban air mobility will be increasing in its autonomy, moving from piloted to safety pilots to more simplified cockpits and just progressing on. At the same time, the small UAS traffic density is going to grow, and I think some point in the future you're going to see those two come together, where that's where the meshing point is going to be. And
go ahead.
Just one more thing about our UTM. The big shift we made in our UTM concept this time was we realized that when we were talking about it as traffic management, we weren't really describing the full regulatory portion of the ecosystem. Mm-hmm. And so that was really the big shift we made in this version, was to start outlining what are the regulatory actions that support that traffic management and how do those two work together. So
fair enough. Xia, I've been tracking EHang, a Chinese company that's developing eVTOL, and they've been working with the authorities in China to evaluate how electronic fences could be a way to safely contain autonomous operations in congested areas. Is that an approach that Honeywell and others in the industry are looking at, or are there other technologies that you think would achieve the same important safety results?
Yeah, it's very interesting. I have also been tracking EHang. They're really pushing the field forward and trying out, kind of venturing out and trying different business models with UAM as well. On electronic geofencing, it's been an important tool, right? We do it on small drones today, and I have no doubt that static and dynamic geofencing can help ensure public interest and public safety. But tagging on the UAM ConOps discussion, you can also think of the UAM service corridors that's been discussed, which allows vehicles to go, enter the corridor and transit between vertiport to vertiport. That's really kind of a geofencing as well, because you're contained within that boundary. So in that sense, it's kind of a central concept to finding a pragmatic approach to enable initial autonomous or semi-autonomous operations. But I think I want to highlight that, conceptually, this is pretty simple, right? We have in our mind these, volumes in space that's being cordoned off. But when you get into the details of the avionics and the systems, how do you do this robustly, right? You know where the geofences are, but you need to know where you are as well, right? This is why Honeywell is investing in things like the AH2000 AHARS and GPS INS systems to allow us to have very high integrity and high performance PNT performance, right? We need to know where the vehicle is relative to all of these fences. And we need to do that even in the event of GPS disruptions, right? And I think even with the fences in place, we need to have robust detect and avoid against non-cooperative actors. And this is why Honeywell is bringing to market our RDR compact radar, designed for UAMs to enable robust detect and avoid under all weather conditions. And finally, I think you need to roll all of this together, right? Again, going off the simplified vehicle operation model. Right now, the pilot has additional sources of information in the transition to autonomy, and we have to have simplified symbologies and human interface to represent all of these things in the space, and only show the information that's relevant to help the pilot reach the right decision. So again, it's conceptually elegant, but it's again something that we have to build block by block, system by system, and then integrate to enable.
Good point indeed. Florian, I'd like to go back to you. Let's just say we fully accept the user case for autonomy, the business case, and the safety case that you're mapping out for using autonomy with eVTOL aircraft. How can we be sure that the end users will be convinced of this? I mean, at the end of the day, even if we're all convinced here and everybody in the industry is, ultimately it's the people who are going to get in your Velocity aircraft who have to be convinced. So what sort of engagement has been happening with prospective operators and passengers and city authorities to help them understand the case for taking this step?
Yeah, that's definitely an extremely important point. I mean, you can't design a system without the end user in mind. You usually see what happens with systems where you didn't. They fail miserably, or you have a high cost of changes and a lot of risks in there. So definitely, we past year, I mean, maybe you've seen that and followed that. We were having a lot of demonstration slides, so it was a real high pace that we made there. And part of it was a study on public acceptance. So people were prior to the demo flight and after the demo flight and on the ground and seeing it flying, they were able to really get a first feel. And those were 15, 16,000 people on site in Stuttgart. There were people in Singapore witnessing it live on site. So we got first-hand input and having a lot of the other different events so people could sit in the aircraft, of course, let's say a mock-up, but they could sit inside and they could see how it would look like without a pilot stick, and we could get their feedback. And that was extremely valuable. And we also shared that in the public study, and there are other studies that followed up on that. So, and they all share the same tendency. Once people got a real feel of it and they sat into it and they got it explained properly and they see that it is properly engineered, the look and feel is right, they build up some trust. Trust has to be earned. It's not different than any other case. So from that perspective, we are starting very early from it, of course, because it's not constrained to autonomy. It's about the whole business case that even with a pilot on board, you want to make this a better experience than with conventional aircraft maybe today. So it needs to be a really proper design also for the end customer. But I would also like to mention that the people who are not sitting on board have to comply or have to accept that and have to be willing to have air taxis fly over their heads, more or less. So we are also actively investigating that. Where could be the routes? What are acceptable levels of noise? And we are happy that our design is extremely low noise because we don't build it too big. Also, as depicted in a lot of more these technical details in the white paper from our CTO last year. Where we give some reasons and pointers why we believe it is a good design and that we really have a good sweet spot in the design here. So in terms of acceptance, block number 3 here is something that we released in January this year. It was a project that we did with the Ministry of Infrastructure and Traffic from Germany, where we try to foster some feedback from the experts, but also from, let's say, ordinary passengers on the acceptance of autonomy. So in that course, we also released the video describing a little bit on our vision. It goes into a similar direction to what Jay was mentioning on the ConOps, so that we initially foresee a very let's say, easily acceptable wide bandwidth area of operation. So don't pack it too dense in the beginning. It needs to slowly, step by step, scale up. And then we can take it from there as we learn and then reduce the margins a bit as the data proves that things are safe and low noise and other acceptance criteria that are out there.
Mm-hmm. Yeah, very good. David, at the CAA, I'm sure, ultimately you see part of your role to basically reassure the traveling public, to be able to look them in the eye and assure them that, despite the degree of difficulty, if a system is introduced for commercial operation, you can be sure that it's going to reduce safety that it's going to increase safety rather than reduce it. I mean, is that something that's very much on your mind, and how much thought does CAA give to the need to really engage with the end users that way?
Yeah, absolutely, Charles. And I would just echo everything that Florian said. I think the Stuttgart study that was done by Volocopter is extremely useful in helping to shape the discussions around this topic. We at the CAA have taken we definitely view this as one of the key challenges for highly autonomous systems and for UAM operations in the future. The extent to which the public is prepared to give what we would term a social license to industry to deploy these technologies. I think we can look at some previous instances of where new technologies have been deployed in the public without sufficient consultation. For example, in Europe, the discussion around genetically modified organisms, some of the challenges that have been proven in the use of big data sets in relation to healthcare outcomes and interventions. It is clear that if these types of truly transformative technologies are not properly introduced to the public in a manner that takes account of their concerns and demonstrates the degree to which they can affect the outcomes of the deployments of those technologies, then it is not going to achieve the social license that is required, and it's not going to be a sustainable business proposition, no matter how good the technology case is, or no matter how good the business case is. And so we developed and released 2 months ago a paper and a model on what we call the social license, and it provides some good pointers for how we think industry looking to introduce innovative technologies, in particularly highly automated and autonomous systems, could consider starting to have those discussions with the public. And I think the important point is it's not just passengers, but it is those affected communities, third parties, overflown communities, those for whom the deployment of high fidelity sensor suites scanning in and around people for the first time is going to be a whole new proposition to something something we've never seen before. Aviation is going to be closer to the public in many ways than it's ever been in these use cases, and therefore we have to proceed with the absolutely utmost caution.
Yeah, thank you very much. Simon, we're going to give you the last word after my very disrespectful jibe about turkeys voting for Christmas. But you and your fellow pilots involved in this development work that is leading to autonomy, you're the ones who are having to get along with the proverbial robot in the flight deck. I mean, how confident do you feel that this is heading in a really sure direction, and that, you know, when you're in your local pub, you can look people in the eye who are potentially going to ride in these aircraft and assure them this is going to be a safe way to travel, even if they're not seeing a pilot sitting right there at the front?
Well, it's an interesting challenge, isn't it? We want to increase the level of automation to be able to do more things with our airspace, to be able to increase overall safety. But like David said, it's quite a fragile thing, introducing these new technologies. And if it's done in the wrong way, perhaps even in different sectors, then that could have a very detrimental effect. But I think it's a really, really exciting time for aerospace, because we've got these small, complex aircraft that are more complicated than any civil small light aircraft ever built, right? And what that enables is really rapid iteration of a scale that we've not really seen. We haven't seen since probably the 50s or 60s. Because if you look at big programs, large airliners, fighter programs, 20 or even 30 years is not uncommon these days. Well, we've got hundreds of teams of people working on UAM platforms, eVTOL platforms, and they're designing new aircraft in 18 months. This is happening really fast. So we've got those iterations we can test and iterate and develop, and I think that's the real path to success, and why I'm really excited to be involved today.
Excellent. You're quite right. It is fascinating, and even in these trying times, I think it gives aviation hope that it truly is introducing at very least a generational change, perhaps more than just one generation's worth of change. Well, thank you very much, everybody, for your very valuable insights. We never, ever have time to cover everything, but whether you're new to this field or you're a veteran, we hope that these experts have whetted your appetite to learn more about autonomous flight. Below the window for this session, you should see some resources and some assets on the topic that you can access to learn more afterwards. If tracking information about eVTOL aircraft and urban air mobility is important to you, please, I would ask you to sign up for AIN's new futureflight.aero platform. I'm working on that, and you'll find all the news and a searchable database at that new resource. But I've got even better news than that to end on. Farnborough International will be continuing the Global Urban Air Summit series with plans for a new event in Asia. And also, I'm happy to confirm the return of the face-to-face conference and exhibition, GUAS 3.0, which will be at the Farnborough site, the real Farnborough site, not the online Farnborough site, in the UK, on the 7th to the 8th of September 2021. So not this year, but next year. And they're hoping to see actual aircraft being being demonstrated there in flight. So don't forget to click on the link at the base of this session page where you can save the date for that and register your interest in participating. Coming up next at GUAS 2.0, in the next session, we've got a chance to hear about Embraer's plans in the urban air mobility sector. That's a company that's been pretty secretive, so I hope they're ready to spill the beans at last about what they're going to be doing. And then in the final session for today of this Global Urban Air Summit, Samir Savani from ADS and Robbie Bork from Oliver Wyman will try to draw some conclusions from all the fascinating things we've heard on today's agenda. Once again, to our experts and everybody paying attention to us, thank you very much for your time. We're very grateful to have this chance to learn together.